Hello again, Tom from everystepphysics.com, everystepcalculus.com too, don't forget that one. This is another position of a particle problem. Came up on Yahoo, and so I thought I'd answer it correctly. The two answers, they didn't know how to do this part E here, but I do. And my programs does, and you can too if you purchase my programs. Physics to get to my main menu here. It's all in the instructions of how to type that in or how to get it. I like to press. I'll do that for you quick here. I'm gonna get rid of that. You press second, and then the minus key, which is the variable link, which shows all the programs that are loaded in your calculator. And to get to physics, I want to get the Q one, so here's the Q over the 1. I'm going to press 1, and I'm down in the Q section here of the alphabet, but physics is the P. So I generally go to the alphabet below it so that you can scroll up to it. You scroll up to physics, and it comes up here with physics, and then there's no right parentheses. We have to add that one. Parentheses open and closed there tells the calculator that you want to do a program. So we're going to press enter here, and we're going to get to velocity because that's what they're asking. Velocity, 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 velocity. So then you say, well, let me go to the velocity in the menu. So velocity is at the V. This is the A section of the physics, my physics menu. Well, V is right at the end, so you can scroll down like this for quite a, or you can press second and press that, and your calculator go screen by screen. Or you can do this. You can go up with the cursor here, and then it goes down to the bottom of the alphabet. This is the last program. And so then you scroll up to velocity, press enter, and force in my programs is N, newtons, and force of friction is F, friction force. Then I say match your variables, okay? So we press enter again, and we're going to match the variables here. Well, the variables are x and 2 times. So here's x of t, and T1 and T2, so there's no mass involved here. Mass 1, mass 2, mass 1 in length or radius or constant, of friction. So we're going to choose this one and press enter. And we're going to enter the function here. We have to press alpha first. So I pressed alpha, and I'm going to go 9.75 plus 1.5 times, you always have to add in the calculator times, you have to tell the calculator what to do, times t. Here's the capstan here, and for cubes. And they say it in centimeters, so I try to do everything for you. And we're going to enter the time. T1 is 2, alpha 2, and T2 is alpha 3. I always show you what you've entered so you can change it if you want. The largest number for the time has to be in T2 position. I do that automatically for you. You couldn't screw it up here yourself, but it's just your own knowledge. That's the way the formulas work. So the average velocity, we'll do this. The formula is the quantity here of x t2 minus x of t1 divided by t2 minus t1. Okay, so then we put the variables in. Here's the variables here, x of t2 minus x of t1, and divided by 3 minus 2, which is t1 minus t2. And we do the calculations here. It's 28.5 centimeters per second. I do change it to meters per second just in case your professor asks that or you need that. So now the instantaneous velocity is the first derivative, of course, x prime of t or dx dt. And in this case I'm calling it velocity t. And then of this function here, 1.5 t cubed plus 9.75, okay? And the derivative of that is 4.5 t squared. How do we do the derivative? Well, you take the exponent here of 3, multiply it times the front of the problem, which is 4.5, and subtract 1 from the 3, get t squared. So you could do that in your mind too, but little harder ones, it's nice to have a program to do it. And then we're supposed to find we found the average velocity, okay, now we want the instantaneous velocity of 2 seconds. So we're going to go for number 3 here, other time choices. And we're going to put alpha 2. So at alpha 2, the velocity is 18 centimeters per second. We want to press 1 for other ones because they're asking for other ones here. Press alpha 3. And alpha 3, notice we're putting 3 in for the function. Notice also the 3 here has quotation marks around it. I can't get rid of that with the program and the way the calculator is set up, so you have to put parentheses here, okay? You'd have 4.5 parentheses 3 squared for your paper. And here's centimeters and here's meters. And we want 2.5, so we're going to do one more here. Alpha 2.5. And we've entered 2.5 in here, and here's 28.125 centimeters per second. Now they want the instantaneous velocity when the midway point between the positions now. So we're going to choose number 2, midway point. And now here's the number 2 is midway position between x2 and x3, which is here with these times here, in between these times. But it's the positions, not the time, okay? If it was a time, we would be number 1 here, midway, okay? And of course the midway between 2 and 3 is 2 plus 3 is 5, divided by 2 is 2.5. We've already found we could press 1 here and do it, 2.5, and we could come up with 1.5 centimeters per second. And we could then go back and we go to number 2. Number 2 is more complicated. At x equals 2, we put that in the function as 21.75 centimeters, and at 3 it's 50.25 centimeters. Okay, so now there's a special formula, and the formula is x2 plus the quantity x3 minus x2 divided by 2. So here's what we found for x2, and here's x3 minus x2 divided by 2, turns out to be 2175 plus 28.5 divided by 2. Notice this is not within the division of the 2, and turns out to be 36 centimeters. Now we use algebra and put it in we found this is the midpoint, 36 centimeters, okay, and then we put it into and we figure out how we have to move things around. For instance, 9.75 is subtracted from 36, etc. I didn't have space to do the step-by-step on this, but the time is 2.596 seconds. And you'll get credit for that in your paper if you put it down there like that. And then we put 2.596 seconds into the derivative here. Turns out to be 38.326 centimeters per second. Now we can press quit, and then we can do another velocity problem if you want. Here's the velocity menu, or you can go back to the main menu of the physics and find acceleration or tension or whatever stuff they want you to find. Okay, pretty neat, huh? Everystepphysics.com. Go to my site, buy my programs. You'll never regret it. It's the greatest thing you'll ever use. This is like having a Google Translate calculator in language. If you go to Mexico or wherever, using Google Translate to speak with people, well, that's what these programs are. They're the greatest notes in the world. I've taken the notes from professors online. Of course, this is from a million tests that people have sent me over the years. And that's where I get my information, and it's not easy, let me tell you. It takes me a long time to figure out problems because professors do it in different ways. They show different things different ways. I have to find out what the best way to show it, best way to do the problem. And some professors do problems incorrectly too. Throws you off, For instance, if you go to Google this problem here and Google it and check out the answers for it, you'll notice that the professors didn't have centimeters for the answers. They had meters per second. So I could call them up or text them and bitch about that, but I mean, they make mistakes. My programs don't make mistakes. Okay, a program doesn't make mistakes, people do. So anyways, go to my site, buy my programs, and pass physics. Have a good one. Plus, you can call me and I'll help you. Email me with problems. I'll show you how to do them with my calculator, with the problems. I'll show you, I'll send it back to you, and you know exactly how to do them. I can tell you how to do physics problems too. The reason I'm a genius at physics right now is because I have my programs here. Otherwise, I couldn't. You'd have to memorize it. If you have photographic memory, then you're much better off with these type of things. I don't have that myself. I was a C student in college. Not in college for physics and calculus, but I mean, all high school I was a C student, so I never really was genius at any of this stuff. But now I am because of my programs. Hey, have a good one.